So, looking at GCF, right, we should be thinking about what these two things have in common, these two terms have in common, and then they both have 5 and they both have an x, so bringing that out, right? And so we're undistributing that 5x, and then what do we have left, right? 5x times 1 is 5x, and 5x times -4 would be -20x squared. So this is what's left in. So we factor the 5x out. This is what's left in. We've factored it. We've undistributed. Right? All of these have a 2 in them, and they all have a y in them. So I'm taking that out. Okay? So I don't need a 2. I don't need anything because the 2 is the same, but I am missing an x. I am missing one y. So xy. 2 times 16 is 32. And then we're missing the x. And then 2 times 23 is 46. We already have the y, so we don't need another one. Okay? Does that track with what you guys had? Okay. Sophia, what did you guys get for number 3? Two numbers that multiply to be 24 and add to 11. Okay, Kaylin, what did you guys get for number 3? Two numbers that add to be 24, add to be multiplied to be 24, add to be 11.
8 and 3.
8 and 3. Okay, 8 times 3 is 24. 8 plus 3 is 11. Let's get on.
Yep.
Kamala, what about number 4? Two numbers that multiply to be -49, but add to be 0.
Our group didn't understand what problems we were supposed to be doing.
-7 and 7, I think, right? That's number 4.
That would have been a lovely time to ask for help. You guys could have called me in there and let you know. Thanks, Jake. Let's see. Addison, what about you guys? Product to -27, sum is -6. Two numbers would do that. Kyla, product to -27, sum -6. Okay. Who got that far?
You got a -9 and 3.
9 and 3.
Mr. Baker.
-9 times 3 is
Yeah, it's -3 and 9, right? Oh wait, never mind.
-9 plus 3 is -6. All right, last one. What about product of -36, sum of 16? The two numbers multiply to be -36, but add to be 16. All right, Sam, -2 and 18. Okay. So these unique number combinations, okay, there are no other numbers that multiply to be -36 and add to be 16. There are no other numbers that multiply to be -49 and add to be 0. Okay, those are unique number combinations. That's going to be a part of something that we're doing later, and for you guys to be able to find those number combinations is going to be kind of a key thing. Okay, and sometimes we see it, and sometimes we don't. Okay, and I'm going to show you guys the way to deal with it when you don't see it. Okay, if you couldn't figure out number 5, how do you figure it out? Okay, sometimes you'll just see it. Like you look at number 3, like, oh, 8, 3, bam, easy peasy. But you look at number 5, like, right? How do you move past that? Okay, so we'll go over that. I do not need you guys to write this down. Okay, I just wanted to talk through it. Okay, which again, I just need you guys to be participating here. Okay, so how do we factor a polynomial like this top one? What are we looking for here?
For the greatest common factor.
And what does that mean, Aiden? If you had to tell somebody what a greatest common factor was that didn't know.
You look for the smallest number that goes in all of them.
The smallest?
Or the biggest number that goes in all of them.
Biggest number. So what goes into all of these?
4x.
4x, right? They all have a 4 in them and they all have an x in them, right? It's the biggest thing we get. Okay? And then we should be asking ourselves what, right? Once we decide what that GCF is, how do we decide what goes here? What do we ask ourselves?
You have to figure out from what 4x to 4x with 4, like you have to figure out how to get there. So it'd be x to the third.
Okay, so what we kind of left out there, Sam, is what operation you're using. Am I adding? Am I subtracting? Am I multiplying? Dividing?
You're multiplying.
Multiplying, yeah. What do we multiply 4x by to get 4x to the fourth? Right, and you said it was
X to the third.
X to the third, right? So then what do we multiply 4x by to get 12x cubed? Right? We need a 3 and we need 2 more x's. Right, what do we multiply 4x by to get negative 16x squared? Well, we need a negative 4 and then 1 more x. And then what do we multiply 4x by to get 8x? Right, by 2. Right? So there's that idea that factoring by GCF. You pull something that's common out of everything. Right? Can we do the same thing here?
No.
No, why not add it in?
Well, there's no greatest common factor for everything there.
Yeah, right. So we look at these; they all have x's, right? But 2 doesn't. Right? And these 2 have 3's in them, but these 2 don't. Right? And these 2 have 2's here, but these don't have any 2's, right? So yeah, there's nothing I can take out of everything. Okay, but this is factorable, right? There are things that I can multiply by each other to get this. Right? Just like here, this is the factors, right? If I take 4x times all of this, I get what we started with, right? That means it's factorable. Well, there's something here that's, if I multiply something by something else, I will get this, okay? So let's figure out why we can't do it the way we want to, right? And so the way we're going to do that is by thinking about, what I showed you guys yesterday. The first thing, I do not need you to write this down either. And the first thing I showed you guys yesterday was, how does distribution work? Well, how do we undistribute it? Okay, so let's look at a more complex distribution problem to see how to undo a more complex distribution problem. Okay, so again, that is a really big thing though. There, this is undistribution. When we're factoring, we are undistributing. Okay, and something that's probably been a while since you've thought about, like when you first learned to distribute years ago. Okay, what you were shown was that you take that first thing, x squared, okay, and you take it and then you multiply it by all of this, right? So you would say, well, what's x squared times 3x plus 1? And then also, what's 2, so positive 2 times 3x plus 1. And that's where we started with. We figured out a kind of a faster way later to do this, and then that would be x times 3x, which would be 3x cubed, and x times 1, which would be x squared. And then 2 times 3x, which would be 6x, and then 2 times 1, which would be 2. All right, well, look at that expression there, right? 3x cubed plus x squared plus 6x plus 2. Right? Same expression, right? So these are the factors of this. If I can take this times this, I get this. That means these are the factors, right? So how do we go this way? Okay, how do we factor? How do we break it apart? Right? And so what this method is called is factoring by grouping. Okay, so I do want you to write this down. Okay, so this is factoring by grouping. So here's your second tool in your toolbox as far as factoring goes. And you guys are going to end up with like 5-ish tools, 5 methods of factoring. We'll eventually have a graphic organizer to help you guys kind of keep them separate from each other. Okay. The tool we learned last time was GCF. And then remember I taught you guys that you always try GCF first. GCF is the most basic type of factoring, be able to pull something out of something else, but it's okay. Factoring by grouping only works when there's 4 terms. Okay, so it's a very specific type of tool that we can use. Okay, I'm going to add a step 0 here, which is going to be just GCF question mark. Okay. So checking that first, right? Can we pull something out of everything first? Okay. So it's called factoring by grouping. Right? Our first step is to check to see if there's a GCF. Is there something that we can take out of all of these? Jared, is there something we can take out of all of these?
Couldn't you take 2 out of every one of them?
Okay, we take 2 out of everything. Right? So there is a GCF, so we're going to go ahead and deal with that. Okay, so 2 times what? Right, 2 times x cubed, and then 2 times 2x squared, and 2 times 3x, and 2 times -6. Right, so we did find a GCF. So one thing we have to be really careful, right? Since we have that GCF, that's like the very first thing we did. We're going to have some work after it. We got to make sure that 2 doesn't just go as we work. Right? It's really easy to get focused on what's going on inside the parentheses, and that 2 just drifts off. Okay, so we still need to look inside of here. Okay, so we pulled out everything we could, but now we have more tools and saying, well, there's nothing in common here, but is there something else I can do? And because there's 4 terms, factoring by grouping is your go-to method. Okay, and so the first step with factoring by grouping is to break the problem into 2 groups. Okay, and how that happens, we just use a line, and it goes to the left of the middle sign. Okay, so just cut the problem in half that way. Okay, you cannot cut the plus sign off of the 3. Okay, that's not okay. It needs to go to the left of the sign. Okay? So pretty easy first step. Second step, you're going to find the GCF of each group. Okay, find the GCF of each group.
It would be x squared on b. Oh, sorry.
So June,
Wait, what?
June, what would be the GCF of the first group?
Oh.
What would go in both terms of the first group, June? June, you there? Not quite, Tion. Make sure you're not just looking at the numbers. Mason Upton, what would be the GCF here? Okay. All right, Aiden. What's our GCF?
Yay. It would be x squared.
It would be x squared. All right. So then x squared times what is x cubed? X squared times x. And x squared times what is negative 2x squared, right? Minus 2. See what's going on there, Tion? Okay. So Tion, what would be the GCF of the second group? Okay, 3. Yep. Actually, not quite 3. Oh, sorry, you're right. I'm looking at the wrong thing. 3. And it's positive 3. Okay? So we need to make sure you put a plus sign. So that's a tricky thing here. Right? You have to put a sign here. Usually people are pretty good about when it's a minus, like if they take out a negative 3, they put the minus 3. But I see a lot of people drop off that plus sign, and it has to have a sign in front of it. It can't just be a 3. Okay, so you got to watch out for that. And then t on 3 times what is 3x? Three times what is 3x, Dion? You guys hear me okay out there? What's going on?
Mr. Baker, for one, I've been having internet issues in this meeting, so that could be a problem.
Yeah, Kyla, yep, x, Kyla. 3 times what is negative 6? Negative 2, right, Mason? Okay.
2.
So I need to close that green set of parentheses where the 2 was, okay? So don't lose that. The 2 is still hanging out there. So at this point, there's a built-in check into the problem. Okay? You need to stop and you need to look. Okay? Are things going well? It will talk to you. Okay? Now what I'm looking at is this. These two things have to be the same. Right? Those two binomials have to be the same. And if they're not, then something is going wrong. So this is a built-in check. How you know that things are working. 1, how you know you're doing it right, or 2, how you know the problem is doable. Okay? If those are not equal, if there's no way for you to make those equal, then this problem is not factorable using this method. Okay? You'd just be wasting your time trying to move forward. Okay? Right now, you guys are going to only have problems that are factorable with this method. Okay? Later on, we'll run into some that aren't. So if these two things are not exactly the same, then you're doing something wrong. Okay? And you need to stop and figure out what that is, or stop and ask a question. I've seen plenty of students factor this one, and then start factoring this one, and then realize that something's going wrong, like they get something different. And they're like, oh, but it's just supposed to be x minus 2, so I'm just going to write x minus 2 over here, when their math doesn't support it at all. Okay? It doesn't work. You can't progress from there. You can just make stuff up after that point, but the rest of the problem is just junk. Okay? So you have to make sure these are the same. If they're not, then you need to stop and ask a question, or stop and figure out what you're doing wrong. Okay? Usually it deals with that you're not taking the right thing out, or you're doing some arithmetic wrong. Okay? So stop and check right here. Okay, so where, and then the last step, it is factor out the common binomial. Okay, and what the heck does that mean? Okay, so I'm gonna flip back here real quick. So common binomial, right? So look where we were, right? We were started here. We took out what was the same here, right? Well, the greatest common factor, and we ended up with 3x plus 1. We took out what was the greatest common factor here, which was 2. We ended up with 3x plus 1, right? We're going backwards. So what's the common binomial? Right? So what's a little hard to see sometimes is that this is one term, right? And this is one term, right? A term is something times something else. Okay, so even though there's addition in here, because it's in parentheses, it's all grouped together. That 3x plus 1 is a thing, okay, and then x squared is multiplying it. So x squared times something is a term. And in the same way, the 2 is multiplying this whole thing, so 2 times something is a term. So I have these two terms, but within those two terms, they both have a 3x plus 1. And I can factor that 3x plus 1 out. Well, where did it go? Notice how they kind of went together, okay? Just like here, right? When we say, oh, these both have a 2 in them, right? We take a 2 out. We don't take two 2's out, right? We only bring one 2 out. They both have a 2 to bring out. These both had a and x squared to bring out. We didn't bring out 2 of them. We just brought out 1, right? So as I take that 3x plus 1 out, it becomes 1 3x plus 1. Okay? Well, then where did this come from? Well, that was just the leftovers. Right? We took those 3x plus 1s out. Well, what was left? Right? That's always the question. I take something out, what's left in? So the x squared and the 2 went together here. Okay? So when we factor out the common binomial, what we're talking about is that thing that I was saying, these have to be the same, these have to be the same. There's a reason they have to be the same, because they have to be common. Okay? If they're not common, then we can't factor it out. So when we factor out that common binomial, what I'm talking about is the x minus 2 here. So we'll get x minus 2. Those come together. Okay? And then we look for our leftovers, which is the x squared and the 3. And so those go together. See why we needed the plus sign in front of the 3, because it's x squared plus 3. And then don't forget about that 2. Okay. So this is the factorization of what we started with. If I multiplied all this back together, we would get right back to where we started. And that's kind of a big thing. Okay? These two things have to be equal to each other. Okay? They're just different ways of writing the same thing. Okay? Factoring gives us something back that's equivalent but written differently. We should not end up with something smaller or something like that. And when I've distributed all that stuff back together in the bottom, I should get right back up to the start. Okay? We're undistributing. Okay? And if you're ever asked to check your answers, you do that by distributing to see that you got back to the original problem. Does that make sense? Okay, Kyle?
Yeah.
All right, we're going to do another one. Okay? Then I'll check with you guys to see if you feel like you need another one after that. Okay? Same steps. So first thing we check, right, is if there's a GCF. We have a bunch of no's there in the chat. Okay? No GCF, so we just move beyond that. Okay? So we go to the real first step, which is to break this problem into two problems. Okay? So split it right down the middle. Okay? Make sure you keep the sign with the 9. Okay? Then we look at that first group. Look at the second group. Okay? Samantha, what's common for the first group?
X squared.
X squared. X squared times what, Samantha?
X.
And
5.
and 5, positive 5, right? So x squared times x plus 5. Pamela, what about this second group? What's common?
9.
What was that?
Negative 9.
Negative 9. Good catch. All right, so make sure you're watching that sign. Since it's a negative 9, that first term is a negative. You got to bring out a negative. And Pamela, negative 9 times what?
X.
X and
5, right?
positive 5, right? So plus 5. Okay, so there we've factored each group, and then we stop and we check. What are we looking for there? What do we want those to be?
You want them to be the same.
All right, and are they the same? Yep. So what does that mean? Right, it means things are going well. Okay, we're on the right path. Okay. Well, what happens with those two things that are the same, right? Remember, they come together. So those x plus 5s go out to the front. And then the x squared minus the 9, they go together. And then second, all right? It does not matter what order you write these in. So you can write it like this. Okay, that doesn't matter what order they're written in. The two chunks can move. I can't take what's inside and move it. That has to stay put, but the two chunks themselves can move. Okay? So that's the same thing. Then we just stop and look. Do these have anything in common? Nope. Do these have anything in common? Nope. Okay, so that means we've broken this apart as much as we can. So that means that we're done. Okay, that problem's actually not done. There's more to do. We just don't know how to do it yet. Okay, so often when there's a square still in the parentheses, that often tells you that there's more to do. Because remember what squaring means. It means something times itself. So there's some multiplication happening at somehow. And so oftentimes when there's a square, there's still more factoring to do. Okay, so this one is factorable still. This one actually isn't. So there's a square plus 3, right? This one's not factorable. So we're going to be talking about like how do we know this is factorable and this is not. Okay, we'll get there. So as far as we know right now, this is done, but it's not actually done. Okay. How do you guys feel about that? Do you guys feel like you need another one, or you think you got factoring by grouping?
Those seem pretty easy. I think I got it.
Aiden's feeling good. Anybody else think got it? Kyle's good. How you feeling, Caitlin? How you feeling? Caitlin's giving me a thumbs up. I think it might have been sarcastic though. June? Okay. All right. So what happens when we don't have 4 terms, right? We just learned how to factor for 4 terms. What if there's not 4 terms? So this is called the AC method. And this is probably the most important of the methods of factoring you guys are going to learn. Okay. So big deal here. Right? Again, we're going to learn about 5, I think, total. This will be the most important. Yesterday I started the class off by trying to say, like, why do we need to know to factor? And we got to the thing where I was wanting you guys to find the answers to this. We wanted to find the x-intercept for this problem, but we don't know how to solve that equation. Factoring using the AC method is the way we get to solve this equation. Okay? How do we figure that out? What we couldn't figure out yesterday. How do we get there? Okay, we're not going to be there yet, but this is going to get us there. Okay. So the AC method, the most important of our factoring methods. Okay. This is going to be really the one that's going to follow us over and over and over again. Okay. So we saw when GCF stopped working, what did we do? As long as there's 4 terms, we were able to break it apart. And notice how we used GCF in order to help us do factoring by grouping, right? It was still in there. Well, now there's not 4 terms, so I can't break it in half. So what do I do? Okay. So the AC method, the first step is one that you guys will eventually move past. It's just find A, B, and C. Okay. This is in standard form, right? So A is our first coefficient in front of the x squared. B is our second coefficient in front of the x. And C is the constant. Okay. Again, eventually you guys will just do this in your head. You'll say, okay, there's A, there's B, there's C. We'll just identify them. Okay. But right now we're going to write them down. Step 2, why it's called the AC method. We're going to multiply A times C. Okay, I'm going to do that over here. Okay, so my A value is 2, my C value is -9, it gives me -18. Okay. Step 3 is the key step. Okay. So this goes back to what I had you guys do at the beginning of class. We need 2 numbers that multiply to be -18, but also add to be -3. Okay, so we're going to find 2 numbers whose product is AC and whose sum is B. So this is the key step. We need to find that unique number combination, right? We talked about earlier that there weren't any other numbers that would do those certain things. Okay? Find 2 numbers whose product is A times C and whose sum is B. Okay? And so there's a little notation that I use that, okay, it's just how I like to write it. Okay, if you watch a video like this online or something like that, you won't see the other person do it. It's kind of just a little shorthand. Okay, so we just found our AC. We need two numbers that multiply to be that. Okay, but I also need them to add. So I just draw a little arrow, and right now I'm going to write the word add on it. Later on, I'll stop writing that. Okay, I also want them to add to be -3. So I need two numbers that multiply to be this and add to be that. And some of you guys are going to look at that and go, I know those numbers right now. And some of you guys are going to be like, I don't know those numbers right now. Okay? So what do we do when we can't? Okay? Because there's going to be a point where you guys are all going to run into one that you don't know how to do. Okay? You can't just see it. So what do you do when you can't? And so what I call this is just kind of a grind your way through it method. Okay? You need a calculator or you need to know your times tables really well. Okay? You're just going to start at 1. 1 times what is 18? I'm going to ignore the sign. I'm just looking at the 18. Okay? 1 times what is 18? Okay? Of course, that's 1 times 18. And then I go to 2. 2 times what is 18? Well, 18 divided by 2 is 9, so 2 times 9. 3 times what is 18? 18 divided by 3. Type that in your calculator if you don't know it. That's 6. Okay? 4 times what is 18? 18 divided by 4 in your calculator. It gives you a decimal. Okay? We do not use decimals when we factor. So that one's out of there. Okay? So I just draw a line like that. Doesn't have an answer. 18 divided by 5 doesn't have an answer. The next number I write down is 6, but I've already got 6 in my list. So what I call this is hitting the loop. I don't need to write 6 down because I already have 6 down. That means that 5 was the last thing I needed to worry about. So I'm done. These are all of the factors of 18. These are the only numbers that multiply to be 18. Okay? So now I need to find which of these multiplies to be -18. So now I'm paying attention to the sign. It's -18. All right, so is it -1 times an 18, or is it 2 times -9? All right, but I need them to add to be -3. So out of this list of numbers, how am I going to get those to add up to be -3? Well, 3 plus -6 is -3. So there are the two I need. Okay, so then I just start messing with the signs. Which one's going to be negative, right? Because one of them had to be negative, so which one is it? And then start trying to find 3, or -3 in this case. Okay, so there's step 3. Find that unique number combination. Okay. The problem I have sometimes, with students is that they just start guessing, like, oh, 2, and then a 4, and then 7, and 1, and 12. Like, they're just guessing, and they guess like 12 times before they finally hit 3. But if you're just methodical about it, right, you're going to find it faster most of the time. Okay, you could get lucky and guess on the first time, but we're not going to be doing giant numbers. So these lists that you guys have to create won't be giant for the most part. Okay, you just start working at it. You'll get them down real quick. And again, the more you do it, the less you'll have to do it, because you'll just start remembering your multiplications better. Okay, just getting your brain going on those. Okay, but this is the way to do it when you can't just see it. Okay. So what do I do with those numbers now that I have them? So we're going to rewrite the problem with those numbers in the middle. So we're going to rewrite the problem with those numbers in the middle. So what I mean by that is I'm going to take that 2x squared and that 9, that -9, those are not going to change. What I'm doing is I'm taking that positive 3x and that -6x. Okay? So what I'm doing is I'm taking this -3 right here, guys, and I'm breaking it. -3 is no longer -3x. Okay? It's now positive 3x minus 6x. So we found a unique way, right? Two numbers that add up to be -3, but that also multiply to be a times c. So I have to break that -3 in a very special way. I can't just do it any old way that I want. It has to be this exact way. These two numbers multiply to be -18, and add to be -3. Okay. Now that there's 4 terms, how do I factor this? What's our last step? Now that we have 4 terms, how do we factor it? Factor by grouping, right, Sam? So last step is to do what we just learned. Okay? So if you don't know how to factor by grouping, you can't do the AC method. Okay? So see how it builds, right? And if you don't know how to do GCF, you couldn't do factoring by grouping. Okay? So we had a problem with 3 terms, which meant we couldn't do grouping. So to fix that, we found a way to write it with 4 terms, right? We had a problem where we couldn't find a GCF out of the whole thing. So how did we fix that? We broke the problem in half and looked at just parts, right? What are the GCFs of each part? Okay, so we broke that problem in half, right? Well, here we couldn't break it in half because it was 3 terms. Well, so we found a way to break it. Okay, so the AC method is really about how to take a 3-term problem, sometimes a 2-term problem, and rewrite it as a 4-term problem, and then factor it the way we know how to factor 4-term problems. So we break it in half. What did 2x squared and 3x have in common?
X.
X, and then it'd be x times 2x, and then x times +3. And then what do -6x and -9 have in common? Yep, -3, right, Sam? And then -6 would be +2x, and then +3, and then we stop and say, is this going okay? And we say, oh yeah, those are the same, sweet, it's going great. And so those 2x plus 3's go together. And then we look at our leftovers, the x, oh, it's not an x, what's going on? Oh yeah, that's right, here we go. The x minus 3. So the x minus 3. Okay? So here is our factorization. If I multiply those 2 things back together, we'll get right back to where we started. Okay? This is equal to this. Okay? It's just a different way of writing it. It's a factorization. These 2 things multiply to be that. Does that make sense, Sophia? That make sense, Brian? How about you, Mason Hare?
I'm good, thanks, Mr. Baker.
Okay. I want to see if I can do 2 more here in the time we have. Okay. So I'm going to do x squared plus 11x plus 24. Okay. So first thing I want to do is just identify what A, B, and C are. Okay. So A equals, B equals, C equals. Right, again, eventually you guys will stop doing this. You'll just look at the problem. So A is 1, B is 11, and C is 24. Okay. Now I say, what's A times C? So what's my AC equal? 1 times 24, which of course is 24. Again, you guys won't necessarily need to do this later, right? You'll just start doing it in your head, but right now I'm just writing it out. Okay, you'll just say what AC is, and you'll just do the math in your head, or your calculator, whatever. But I need that to also add. So I need factors of 24 that add to 11. Okay, A times C add to this. So factors of 24 that add to 11. Again, some of you see it, some of you don't. What do you do if you don't? Start at 1. 1 times what is 24? 2 times what is 24? 3 times what is 24? 4 times what is 24? 5 times what is 24? 5 doesn't go into 24. 6 times what? Oh wait, I already wrote 6. I'm done. Those are all my factors of 24. Now I start looking for them to add to 11. Okay, if I have a positive number that adds to a positive number, that means that I must be doing positives, not not two negatives. So I need two numbers to add to 11, 3 and 8. What do I do with that 3 and that 8? The x squared stays put. The 24 stays put. Okay? That 3 and that 8 are a way of breaking up 11x. So it's not just 3 and 8, it's 3x and 11x. So plus 3x plus 8x. I think I said 11x. Right? So 3x plus 8x is 11x, right? So this equals, right? These are equal to each other right now. Okay? Break it in half. X squared and 3x both have an x in them. X times what is x squared? It's x times x. X times what is positive 3x? Be positive 3. Eight and 24, right? Do you recognize that? Do you need to do some GCF work that we did yesterday? Do you need to do the sock method? Anything like that? All right, but do you recognize what that both goes into? What if you get it wrong, right? You're like, oh, they both have 4 in them. Okay, so you say 4. 4 times what is 8x? It'd be 2x. 4 times what is 24? It's 6. And then you go to do your check. And you go, ah, crap, right? They're not the same. They're supposed to be the same. They're not the same. Oh, I'll just erase it and say that was supposed to be an x plus 3. What's going wrong? Okay, we didn't get the right thing out. Should we notice? Oops, sorry. Okay, if you notice that there's, oh, it's not gonna let me do it, is it? There was 2x plus 6, right? 2 and 6 both have a 2 in them, which would tell us that we didn't take enough out. So, okay, so don't force it. They both have 8 in them. Be 8 times x and 8 times 3. Now they're the same. Okay, so those x plus 3's come together, and then the leftovers come together. X plus 8. These have nothing in common. These have nothing in common. Okay. X times x is x squared. 3 times 8 is 24. 3 plus 8 is 11. There is a quick way to check that. Or the full way to check it would be to FOIL it out. Kyla, sorry, what? I just saw your chat. Yes, so Kyla's question, great question. All right, what happens if you do this? All right, that was supposed to be an eraser. What if you do it this way instead? Doesn't matter. Okay. So we break it. What do those have in common? X plus 8. What do those have in common? 3 times x plus 8. There's our x plus 8s. Here's our x plus 3. All right, did it matter? Only for a second, right? This part was different than what I had, but this part's the same. Right? So yeah, it does not matter what way you do that. Great question, Kyle. Okay. If any of you guys have an extra minute, I do want to do one more. It's up to you though if you want to stick around. Okay? You guys have a worksheet in your Google class. Okay, I want you guys to try that. I am going to post a short video with just a couple more examples on it. It's like a 5-10 minute video just so you guys can see it some more because it is so important. So I do want to try to just do one more right now. It'll take, maybe we can do it in 2 minutes. So if you have 2 minutes, stick around. If you don't, then you can head off. And so you guys have a safe break. So. Take care, Caitlin. So here, we see that A is 4, okay? C is 9, negative 9, because C is a constant. And then where's B? Right? B is supposed to be next to the X. Well, there is no X in this problem. So B is 0. Okay? So there's no middle term here. So, which is fine. I don't need a B in order to do this, right? It's called the AC method. It's not called the AB. I don't need a B right now. So take my a times my c, so ac would be 4 times negative 9. And later on, you don't need to write that out. You can just go straight to this. And I need that to add. Now I need that b to 0. All right, so I need factors of negative 36 that add to be 0. Well, if you recognize 36, 36 is a perfect square, right? It's 6 times 6. So if I had negative 6 and positive 6, then I'd get 0. Okay. So what do I do with those? 4x squared plus 6x minus 6x. Notice how I'm putting those x's back on there. Okay, here's 0x, right? There's 0x here, so those x's need to be on there. And then minus 9. Break it. Those both have a 2x in them. 2x times 2x is 4x squared. 2x times positive 3 is 6x. And then these both have a negative 3 in them. Negative 3 times positive 2x and negative 3 times positive 3 would be negative 9. These are the same, so they come out together. And then here are my leftovers, 2x minus 3. A little quick one there. Okay. Again, I'll do a short video. Won't be a long one that would take you all day to watch. It just be short. Then I'll have the one from class. Then I'll also have a short one, just as a couple quick examples.